area, okay. In this area, water and soil loss and water pollution are the main problems. This area, this is the lowest plateau. Mainly, my province is situated in this area, in the middle stream. And the downstream is the North China Plain, where Beijing, Tianjin, and Hebei situated. Beijing, you have heard a lot of its name. It's in the downstream of the Yellow River Basin. In this area, massive floods. It has a lot of rains. So in this area, floods is the main problem. My research area mainly focuses on the middle part. Yes, let's come to the middle part, the Yellow River middle stream. This area has arid and semi-arid climate. So precipitation here is not that much, maybe 200 to 400 millimeters. Yeah, and its ecology is very vulnerable. So once there is a small human activity, the environment will be changed. So this area is very vulnerable. This year's many researchers have done their studies in this area because this area, this area is the hometown of the President Xi Jinping, the president of China. That's why lots of researchers focus on this area. So research is also political, right? And from this maps, we can see some developments in this area. The left one shows the night light intensity of 2000 and 2013. We can judge from the night light. This area has developed a lot, right? Night light means there are more people, more developments. And the right part shows the land use tabs. We can see from the land use changes from 1982 to 2015, the forest and grassland increases a lot because China has some policies to recover the environment, to recover the ecology in this arid and semi-arid areas, because everybody wish to make president's home better. And this study mainly focused on the land use impacts on the groundwater quality because we investigated in literature and found that land use indeed can have significant influence on groundwater quality. But what is the influence? How it can influence the groundwater quality is not clear. That's why my students and I did some research on this topic. And of course, the entire middle stream of the Yellow River is very big. We select a small one as a case study. This is the Wuqi County. Wuqi County is a county located in the middle of the Yellow River middle stream. And this is climate. Yeah, the precipitation is less, but the evaporation is intense. And July, August, and September, in these 3 months, we have the largest rainfall. And you can see this some rivers, small rivers, and some of them are seasonal rivers. That means in rainy season, it has some water, but in dry season, no water in the river. This is the hydrogeology. I will not introduce this. So how can we investigate the impacts of land use impacts on groundwater quality? I gave a framework. First, we have to assess the groundwater quality to understand its status. And then we have to extract and quantify the land use and the land cover information. we got the two information. One is the water quality, the other is the land use. Then we establish a relationship between them and find a relationship between them. That's to determine the relationship between groundwater quality and the land use, land cover patterns. And for assessing the groundwater quality, we used the entropy water quality index. Of course, if you did similar research, you can use different water quality assessment methods. Yeah, there are many different water quality assessment methods. And for extract and quantify land use, land cover information, we got some remote sensing image from the institute. And then we analyze this data and got the land use information. And then we used the correlation and correlation analysis and the random forest to set up the relationship between groundwater quality and land use impact, the land use changes. This is the process of extracting information of land use, land type changes from the remote sensing image. I'm not an expert in this topic. My student did this. And in this part, the most important concept is the contributing area. This is a domain relative to the sampling size within which the land use, land cover types significantly impact on the groundwater quality. That is, within a well, around the well, there are an area. Within this area, we assume the land use can affect the groundwater quality. Outside of the area, the impact was minimal, can be ignored. So how to determine the contributing area is very important. What size is suitable to calculate the information, to calculate the relationship? This is important. And my students search some literature. And in the past, people used a circular shape to quantify the contributing area. This method has a problem. As we know, groundwater flows from the upstream to downstream. It flows. So this circular area does not consider the flowing of groundwater, right? So later, people use this searchlight shape. They use this searchlight shaped contributing area. This method is superior to the previous one because this method research considered the flow of groundwater. But this one is also not perfect, right? Because groundwater flows underground do not along a straight line. It's a curved line. So my students developed the curved lines stream searchlight shape. So this is much more suitable for understanding the groundwater flow. You know, contaminants transport with groundwater flow. So only we understand the ground flow correctly, we can understand the transport of contaminants. So my student proposed this curved streamline searchlight shaped contributing area. And he also calculate the suitable area. It's very complex, and I cannot fully understand. He is more smarter. He's smarter than I am, so I cannot understand. And the last method is machine learning, and I guess some of you may have understand this method properly than I do. So yes, this is the groundwater quality map generated by the assessment results, based on the assessment results. As we can see from the map, this area has a poor quality. Also this area, also in the middle part, also in the middle part. So this is the groundwater quality in my study area. Remember this character. Why these areas are polluted? Look at this land use maps. Land use maps. See, in previous slide, we can see this area has poor quality, and also in this area, because these two areas has intensive cultivated land, agriculture. So a lot of fertilizers is used in these two areas. That's why the groundwater quality in these two areas is poor. And in the middle, in previous slide, this area has also poor quality because you can see this area is occupied by urban land, because this is the alluvial plain. As I said, this have small rivers. You know, people live along the rivers. So this area has a relatively high population. So urbanization here is intensive. So the urbanization has caused some pollution to the groundwater. This is our judgment from the two maps. We have to set up the quantitative relationship. So we quantified the land use patterns. Different land use were found there. Here, let's check the groundwater quality and the loess. We have a lot of loess here because it's a part of the loess plateau. But you can see the loess does not have high impacts on the groundwater quality. From these two maps, you can see there's no direct correlation. And this is the forest. But this you can check. With more forest, right? No, with less forest, the groundwater quality is poor, right? That is to say, more forest will improve the groundwater quality, because forest means less human activity. Also, this is a grassland. Here, in this area, grassland is everywhere. It does not have significant or direct impacts on groundwater quality. This is the cultivated land. We can see from this map, this corner and this corner, they have a lot of farmlands, cultivated land. So the groundwater quality in these two areas is poor. This is the urbanization. You can see in the middle, we have an intensive urbanization. This urbanization has caused groundwater quality in this area. This is a Pearson correlation coefficients, and this result has indicate the correlation between different land use and the groundwater quality. So it takes some to explain it, and from this table we can see cultivated land and the water level elevation has more impacts on the groundwater quality. As I said, cultivated land means for agriculture, a lot of fertilizer used. And the grass and the lowest unused land and the urban land, also urban land has a negative impacts on the groundwater quality. but grassland and forest, they have a positive impact. That is to say, forest and grassland can improve the groundwater quality. This is a result from the random forest, and we can see the random forest can be used to calculate the relative importance of the predictors to the responsive variable. That is to say, random forest can predict the impacts of land use on the groundwater quality. Okay, now let's come to the last part, challenges in groundwater protection and research in Northwest China. And I think this part is also applicable to other areas. Challenge, first I would like to say something about the challenge. You know, groundwater science, or we can call it hydrogeology, is a comprehensive, multidisciplinary, and complex research field. It involves both natural science and also social science. And as I said, research is also political. So this is also associated with political issues. So natural science such as geology, hydrology, ecology, geochemistry, and many other natural science, and social science, physiology, anthropology, sociology, and many social science. These disciplines joined together affect the research of groundwater quality. You know, groundwater system itself is very complex. By adding these affecting factors, the groundwater research will become even more complex. And also complexity in China, in Northwest China, because the inherent of groundwater system, the system is complex. This is a well-known fact to our hydrogeologists. And also in Northwest China, we have a diversity. We have diverse human activities, agriculture, industry, and many different types of human activities. This different human activity can induce different impacts on groundwater quality. And the third, the study area is complex. You know, China is a big country, and this country has a lot of a large population, and we have different races. We have a Han, we call it Han majority. I'm Han, different races. And we have another 55 minorities. We have different races. We have different languages. Though the minorities, they can speak Chinese, but they sometimes usually speak local language. We cannot understand the local language easily. So when we go to the field, we have to think how to communicate with the local people. This makes the research very complex. Yeah. So this is the complexity. And the long term, as I said, humans development, the society development is a long-term task. With the development of human activity, human society, the groundwater quality, the groundwater research will develop. So the development of a human society is long-term. That makes the groundwater quality research a long-term task. And also groundwater problem treatment. Once groundwater is contaminated, it's difficult to treat it, to treat the contaminants. This is a long-term task. And also, groundwater research requires some advanced technologies. You know, developing new science, a new technology is difficult. It requires a long time, right? And also the uncertainty, human activity is uncertain. We have different type of human activity. Also the policy, the national policy. If the national policy changes, researchers have to change their research direction. This is especially important in China. If the national policy changes, research have to change their research direction. Otherwise, they cannot get financial support from the government. Yeah, this makes groundwater research very challenging. And the last, I would like to introduce some of the journals. I'm an associate editor for these journals. So welcome to submit your papers to our journals. And we can edit some special issues in this journal. They are also very good and have a high impact factor. And we have edited some special issues, and we can collaborate further to edit some more special issues. This is the Springer Hydrology. I was invited to be a series editor for this book series published by Springer. Before I came here, just 1 week before I came here, I was invited to be the series editor. So if anybody wish to publish a book in this book series, you can contact me. The book can be edited book or authored book, or even conference proceeding. This book series can publish different types of a book. And this a local journal published by my university. It's a journal published in Chinese, but it also accepts the English manuscript. This is a journal published by China University of Geoscience. It's also a very good journal, also accepts the English manuscripts. Also, this is another one published by China University of Geosciences. This is the South to North Water Transfer Project. This journal is set up based on this project. So it it publishes a lot of papers on South to North water transfers. These two journals are international journals. Journal of Earth Science in English, it is a SCI indexed journal. It has an impact of 3, maybe. I guess it's 3. Last, we have 2 special issues now. One is in environmental research about the coastal ecosystem and climate change. And the deadline is November 15. So we still have almost 20 days, 15 days, 20 to 15 days, 2 weeks. If you have prepared a manuscript, you can submit it to this special issue. It publishes papers very quick. And the right one is a special issue, a review special issue published to be published in Water, and Vetri is a co-editor. And this is an open access journal, but for this review collection, you can publish your review paper free of cost. I can ask a 100% discount for invited papers. So if anyone wish to submit your review paper to this special issue, you can contact me or Vetri. So this is my end of the end of my talk. So let's join hands together to protect our groundwater quality in the world. Thank you so much.
Thank you, Professor Lee. Really, it's a very interesting presentations. We understand thoroughly about the land use, land cover changes, how it is impacted on the groundwater system in lowest plateau. Yeah. But it's a very valid presentations. The colleagues, any?
Yeah.
I have 2 questions.
Okay.
The first one is that when you say that groundwater quality, are you assessing to see the maximum extent of the contamination coming from industrial or factory from there, or it's a natural process or man-made source? So if you're able to quantify or just give you a rough idea.
Yeah. In northwest China, the contaminants from mainly from 3 sources. One is the industry, mainly the second is agriculture, and the third is the natural origin. In most areas in northwest China, fluoride, arsenic are mainly natural origin. I think this is very common in many parts of the world. Fluoride and arsenic, they come mainly from nature. But nitrogen and some metals, nitrogen is mainly from agriculture. This is a common sense. And but in rural areas, nitrogen is also come from domestic waste. In rural areas, the villager, they discharge many wastes into the environment, such as the food. They cannot eat all the food, so the waste food, they pour it into the environment. And the toilet, not like here. The toilet, you have never been to the village. The toilet is a big problem. This caused nitrogen pollution in rural areas. But in northwest China, the most important sources for contamination, for nitrate contamination, is from agriculture, because the entire northwest China is the base for food, for agricultural production. In all these 5 provinces, agriculture is more important, very important. So in this area, nitrogen is mainly from agriculture, and heavy metal pollution mainly from the industry. We have lots industries such as metal melting, and we have many different types of industries, because this year, previous China focused a lot on East China. East China along the coast, they are more developed. That's why they have previous Chinese government focused a lot on the coast cities. They wish the coastal cities to be developed first, and then this year they have shift their focus to northwest China. They wish the underdeveloped northwest China to be developed now. So more industries in northwest China, and heavy metals, mining, also industries cause this heavy metal pollution. Okay, and we also have some organic contaminants also coming from the industry.
And second question is that we care about. For example, I'm from atmospheric science, so we have a lot of atmospheric pollutants in the air. So when it comes mixed with the rain, then it will be contaminated as well.
Yeah.
So have you looked at it, the air pollution into the rainwater contaminations, or the contribution of that? For example, let's take nitrogen dioxide, sulfur dioxide, methane, so the carbon dioxide. So they are available over the vertical region of the atmosphere.
Yeah.
So when it comes in terms of rain, so they may be mixed with the water and form as acidic rain, and then maybe coming into the ground.
Yeah.
So any ideas in that?
Yeah, you're right. The entire Earth system is a combined one. You cannot ignore any part of it. But for my research, I focused on the groundwater only. But I know some research groups in China, they focus on the precipitation and the infiltration of the polluted rainwater. How can the polluted rainwater affect the surface water, and how to affect the widowed zone water? We have groups research this, but my group, we do not do this. Okay. Okay, thank you.
Yeah, I have two questions.
Yeah.
Two questions. One is, what has been the impact of climate change on the land use?
Climate change.
Yes, on land use. Is it affecting migration, the type of industry that you are having, you know?
Yeah.
Because if it's not now, it's going to affect it in future. The government is trying to move in there because it will actually determine the types of places, you know, and the population where people are going, particularly for groundwater. You know, if you look at it from issue of charge, you know, some areas should be left, you know, you be very sensitive on what kind of industry needs to be cited there because of the rate of infiltration or type of soil there.
Yeah.
So has land use affected the planning in the
Yeah. Your question is what I'm thinking. To groundwater quality, two main factors. One is the climate, maybe. The other is the human activity. These two factors actually they connected. You cannot easily separate them. Even though in my research I focused on the land use impact. Land use indicates the human activity. Even though I focused on these factors, actually we cannot ignore the climate change. That's why I'm thinking if we can collaborate together, how to find a good method to separate the impacts. But now I have no idea. I know in my dissertation, PhD dissertation, I mentioned this problem. It's difficult to separate the two main factors. I have also asked my students to continue to this study. But at present, it is still difficult to separate. For hydrology, I know some people, they have some methods to separate the impacts from climate change on the river runoff and human activity on the river runoff. They have some methods, but this method, I guess, not that applicable to groundwater. So I have no idea how to separate these impacts. I hope we can collaborate further. Maybe our BRICS project or UNESCO project, we can focus on this problem, how to separate the impacts from land use and from climate change. Climate change, I can say, is a natural environmental change. Land use is a human activity. How to separate them? I'm still thinking. Okay. Yeah, Professor.
Yeah, very nice presentation.
Thank you.
Yeah. Most of the questions I think they've already read. The relationship of that the groundwater quality you showed that is it really not from natural source or land use?
Yeah.
But not only that, even the climate variables, like when evaporation is high, because the study area is a similar area.
Yeah.
So in that case, the precipitation from the agriculture is its own impact.
Yeah.
But how to quantify this precipitation, the flooding, and the evapotranspiration, all that contribute to that groundwater quality and how to the relationship that. So in my PhD research, I did that.
We did that.
Yeah, I did that. Can be possible to integrate into the GIS system and quantify and identify really the vulnerable points where exactly high level of that contamination is.
Yeah.
So exactly possible.
Yeah, I also read some papers doing the similar things, but I guess the accuracy or precision needs to be further improved. Even in my research, I focused on land use, but I know some natural factors affect the land use. So my research also a complex one. It focused on land use, but you cannot ignore the natural factors.
Yeah. And I think on the last question, I think we already come quickly. Yeah, I think a continuation of the Shiva is asking that one. It's interesting. I can see in your study area the nitrogen but nitrate is more than 700.
Yeah.
Comparatively, it's very too high. But I think that one also the denitrification process also it will be happen. Nitrogen gas is releasing. Maybe the atmospheric science people, the researcher, they can involve in this during the precipitation, how much of precipitation
Yeah.
nitrogen gas is absorbed. That was maybe we can plan.
Yeah.
But my question is here: due to the high contamination of the nitrogen and fluoride also you mentioned, is there any management plan? But really, it's a disastering the agricultural environment.
No.
I can understand this high pollutants. But is there any Chinese government or your local government, is there any management plan to control these pollutions or any limitation for the giving the fertilizer for the farming lands or something? Is there any?
Yeah, of course. In the past,
Hmm.
we do not care about the environment. So the regulation is less regulation. But now this year, China paid great attention to the environmental protection. So there are many regulations released. So the situation I reported in my talk is from previous. You know, China has a long history of agriculture. It's not because today the human activity today. It's because of human activity many years ago. Many contaminants have accumulated in the soil, in the aquifer. That's the problem. And as I said, once it is contaminated, it's difficult to recover. So that's a problem. Even though we have a lot of regulations, the contamination is already there. That's the problem.
Thank you, Professor.
Okay.
Really, it's very interesting discussions.
Okay, thank you.
Okay, colleagues, I think I would like to invite our second presentation, Professor Shivakumar from University of KwaZulu-Natal. You are more welcome, Prof.
Good morning to everyone. Good morning, all of you again. Is that need to do this share screen or? I should share screen. This screen.
One second.
Okay, good morning to everyone again. I hope my talk will not be too much on the groundwater or the contamination or management, but I'm talking on the different objectives. I'm from atmospheric science background. So we do mostly on the physics side of the atmosphere. So my talk here is mainly focused on the case study, what we have done over Durban. You might be knowing it last year, we had a flood, And then we looked at it, what was the atmospheric dynamics which has played a role to enhance the heavy rainfall. So that's what we looking at into that angle there. So as I said, it will be like a case study, but mostly number of physics terms will be used on that. So if you have a doubt, we can also clarify later. With that note, I will just start myself here. So if you look at on these pictures, as I said, I keep this slide more common. As also asked now our colleague from China about the air pollutions, how does it contaminate the water? So if you see on that, on your left side on the top, so what you see, the emissions coming from the power plants. So that is a simulations has been done for about 100 years. So you will see that in 19th century, so we don't have much pollution emission coming out in our continent, like African continent. So you don't see any emissions over there. But when the year moving across, so you will see that by 1960 or somewhere, and then we started to have a lot of emissions coming across into the African region. And also mostly if you see now, we can figure out there is emissions coming from our power plant. The one is, that ESCOM, we had a lot of power plants there. So it has been now growing too high. And then we need to take up some kind of actions how to protect our environment and cover these emissions which is coming out into the atmosphere. So that was one of our objectives, to looking at different air pollutions in the atmospheric research. And then below what you see there is a two animations there. The one on the bottom on your left-hand side, which is the CO measurements. On the right-hand side, you have ozone measurements. So again, you can see that the improvement, I mean here ozone is a ground ozone, so that we call it a pollutants, that. So again, you can see the emissions of CO and ozones nowadays, that is increasing as well. Okay, so those are, I said, like air pollution or which is impacting the atmosphere. But the other side of it, I have put again on the right-hand side, one up and one down. So South Africa has a large climate zone. One region of South Africa, you see drought, no water. And whereas in the other side, like what we have in KZN, we have a large amount of water. That's like a rainfall and floods and everything there. So we need to see again, that could be interesting to see how we manage this water to potentially to use where we have a drought and everything to be covered up. So that is the interesting part. So the reason I presented here, so that is a flood which we have occurred last year in 2022 during April. Okay, so that's my motivation for the study here. Okay, so as I said, I will be focusing on that topic. If you know my name is too long, people always complain that. So that's why I just underline my short name, Siva. So it's easy to pronounce. If you need to contact me, you can contact. Again, I keep my 2 email address. Again, people make mistakes when you write email address. So both the email comes to me. So I work for seconded by DSI. So I work for NAS program. That's a space science and astrophysics program. So you can use the simplest one, what you prefer to contact me. Okay. So the NAS@UKZN or Venkatraman S@UKZN. So both email comes to me. I will be happy to respond to that. So besides that, what we do in the atmospheric science and my role, we also have established NITEX. NITEX is called National Institute for Theoretical and Computational Science. University of Zululand is also part of that. So now we are trying to establish a hub in KZN, working with the people around in KZN region, mainly on mathematical and computational science for atmospheric studies. So again, people who are interested can be part of that as well. So, as I said, I just introduced a little bit on my research group, then I will go into the particular to the case study later on that. So if you look at on this slide, again, I'm not sure how many of you have seen before. So this is like we built up the site. So what you see on that The first one is the temperature profile of the Earth atmosphere. So you will see moving from troposphere, stratosphere, mesosphere to ionosphere. So we cover up almost all the region of the atmosphere using different instrument and different measurements. So the other side, you have pressure profile and the density profile. So as you know that the pressure and the density will exponentially fall with respect to the height if it is increasing up. So as to say that our research has been focused from the ground until to ionospheric region, and we also do some kind of study relevant to space science as well. Okay, so this is for our colleague from China, where we are here, and you know, that's African continent, South Africa, and then we are located in Durban. So again, our Chinese colleague, if they want to come down, they are most welcome to come and see us there as well. I'm based at the Westville campus. We have too many campuses in UKZN, so we have 5 campuses. So I'm based at Westville, and there is also a campus at PMB, Peter Marisburg, and there's one in Edgewood, and there's a Glenwood. There is a Howard College or engineering campus, and then we have medical campus in the city. Okay, this is current our team group. You might be seeing Emeka is also here. So he will present about drought modeling, which using artificial neural network. So he will give his presentation later today. So where we will be using artificial neural network to establish, or our idea is to forecast what will be the condition in South Africa using mathematical model and simulations there. Okay, so there are a couple of PhD students and a couple of master degree students currently involved. I'm glad to say that we just finished with Kwanele. One is at the right end. She is a young student doing honors degree, but as I said, we are from physics background. So we built up a sensor now, which is called as a low-cost air quality sensor, to come up with a solution for the government. And also we are tapping with South African Weather Service. We want to sell our sensors to them instead of they buy from overseas. Because this cost of the sensor is almost like 10 to 20% less, which they are procuring from USA or Germany to launch in the balloons and everything. Okay, maybe in the afternoon, if you are happy, I will put the system here and you can test it as well. So the sensors here, I brought it down in my case. You are more than welcome. And if you have people who are interested, if you want to even to test it, we are happy to give it to you. You can test it on your place and then give it back. Or if it is very low cost, we will give it to you for donation. That's not a problem. Okay. So this is like what we call as an automatic weather station. So the cost of automatic weather station is, in general, is about 180,000 rands if you want to buy one. But as I said, we did now the prototype the first time using honors degree student. It was a honors degree student who completed research project with us, with electronic colleagues from electronic engineering. So the cost is 10 times less. So then you can imagine we can able to produce such kind of instrument locally in South Africa. And that idea is to promote atmospheric science and atmospheric measurements in the country as well. Okay, so otherwise, yeah, the study is focused in the large domains and everything. So I don't go into more details, just to keeping to the topic later on. So again, as I said, the reason why we are building this low-cost instrument, because South Africa has lack of air quality measurements, or the measurements to be in different places. So the one reason is, including African continent, is the funding and the financial issues. So that is the reason why we are now getting into low-cost air quality instrument. But otherwise, we have few instruments which is currently in use at the university. And we also mostly use number of satellite observations which has been used. In earlier years, I was being used with NASA. We used to give our data, which we will download from our resources at UKZN, but we will also distribute that data to African continent if the people have a problem to download. Nowadays, it's fine because you have a network is good now. In earlier years, we had a problem of the bandwidth, and there's a connectivity issues and everything. So some of our colleagues from Ethiopia, Botswana, people from Zambia, and also Zimbabwe. So we provided those data under similar condition what NASA has provided to us. Okay, so those data is any case, if people need it, we might have this data. So if you don't have a time to download or anything, then you are more than welcome to contact me. So we will be able to share the data if you need it as well. Okay, so these are the few instruments which we have at the ground based. I put the colleagues who have funded or the research project which has been funded across there. So we use the server again for atmospheric remote sensing. So we also built an online course, which will be called as the Atmospheric Remote Sensing Education and Training. So if any young researchers or young person who want to go into the atmospheric science, if you need to learn something basic, you are more than welcome to contact us. If it is an online course, or if we normally do it like periodically every year for a 1 week or 10 days. And most of the time we will tap into the government funding. If you get the funding, then we will provide you with the travel funding, and accommodations will be included there. Okay, just watch your eyes, and then maybe we will come across sometime there. So far we did about 6 training workshops with us. Okay, those are some picture of the satellites. Just move that. I'm going into the thing. Yeah, so I'm not sure how many of you know that in South Africa, we have that pollution, which is a more widely topic. And it's also been attracted by European unions. So we did, we call it a safari campaigns that was done in South Africa, along with the USA and German and French colleagues there. So that was done about 20 years ago, and it has not been revamped, and it's not been re-looked at it, what is the current situation. So what we did last year, we did this biomass burning aerosol campaign in Kruger National Park. So that was done 20 years back with the European Union project, just to check what is the current situation of the pollution level there. So we used a large number of instruments. We put together into one place, and then we addressed the situation, how the air pollutants, not only on the ground level, also in the vertical directions. So we launched some balloons with the particle counters, and the balloon have go until to 30 to 40 kilometers. And then we track the balloon, and then we bring back the instrument. And if we are lucky, we got the measurements, then we will relaunch it again. So, but we did it 3 to 4 launches. So there are a couple of articles to follow up now. And next year, we are going to have similar project. Again, thanks again of my colleagues from China. So we have the research project with Zhejiang University, and where we want to have high spectral resolution data to quantify the pollutions on the aerosol continent. So the aerosol is like a particulate measurements, but it doesn't quantify exactly what kind of a pollutions or what kind of pollutant it is. But if you have a high spectral resolution, that means you will resolve it in terms of wavelength, then you can able to quantify exactly. Okay, so that objective is going to be next year. We will process it. So these are some of the instruments we have used, and you can see on that on the last end we have a trailer that combines all the air quality measurements which has been undertaken there. Again, this data currently is being shared along with our partners. But again, people, if they want to use it later on, you are more than welcome to use. I'm not sure how many of you know that site. This is in Kruger National Park. If you go to Kukusa Gate, so there is a Kukusa research site. So that's where we parked up all the measurements. Then we also did at University of Wits. There is a University of Wits rural camp in the another gate, where we launched the balloon and measurements and everything we took over. Yeah, so with that, that's what, just to give some brief overview of what we do. And coming to the point, again, as I said, I don't want to make you bored. So I will make it short and then give some concluding results on that. So as you know that my interest or our interest is how we can be able to give our research to the public. So this is also a common one, which we have taken recently, along with my colleague, Faranas. She came from Canada and she used to be with us for a month or two. And her interest is to look at extreme conditions. So then last year we took as an extreme condition was the flood, which has been occurred here. So we also worked recently, we also published from this year, we had the heat waves. I'm not sure you know that. That was happened in January 21st or 22nd, where we have extreme heat, which has been observed in South Africa. So we also published that result as well. So we are looking at extreme climate conditions in South Africa. That includes the heat waves, like a heavy rainfalls and a flood, and like a drought. So as I said, my other postdocs will be looking at, when we have kept down zero water. So we're just looking at the situation, why it has been occurred and what was the situation behind, whether we are expected to happen again in the future to make our prediction, whether it will be possible or not. Okay. So this article is part of that book, right? The one we have, yeah. So we published along with Vetri and Lee, who are the editors of the book as well. Okay, as I said, why we did, because you know that the rainfall is common anyway, but why it is interesting to do this study. If you know the date, it's 11th of April, which has been occurred here, but there were 430 people died across the province. And still now we don't know, the number of people are missing. So we don't know where they are, under the ground or above the ground, we don't know. We need to find. So this is a big disaster which has been called, and even South Africa called as a natural disaster in 21st century. And I will go back to next slide. I will show you how this flood occurred before. I will show you that later on the next slide there. So the government has looked at the infrastructures. So we lost about approximately 17 billions, and that corresponds to almost like $1.5 billion of US dollars. So you can imagine that what is needed for the flood management, and if you take into account, and also mostly I know the money is one thing, but the life is the second one. The people will be losing their life. So as I said, this flood has been occurred more than 3 or 4 decades. So 1987, we had a similar flood in South Africa. That happened on 28th and 30th of September, almost in the same part here in KZN. And we have lost 400 human beings. And then almost like 50,000 people have lost their home. And the millions of money has been lost, like 400 million. But I have to say that 400 million in 1987, it could be, if we converted today, it will be more than 4 billions. So just to look at it, that is the reason for that. So that was our reason to look at why this has been occurred. What was the atmospheric contribution to make this heavy rainfall in the location there? So that was the topic which we had taken and analyzing it. So just to look at, this is the South African Weather Service. They have also given the warning message, and then you can see that what is the expected rainfall over Durban regions. We had almost like a 200 to 400 millimeter of rainfall in a day. So 200 millimeter to 400, that is 20 centimeter. If you know 20 centimeter, that is equivalent to, if you use a bucket of 30 to 40 liters bucket, I don't know, maybe 50 liters bucket if you have. So that is a rainfall which you are accumulating. So that's one drop. But if you look at in the whole region, then it will be too much. So we are just looking at like one point of observation. So you know the rain accumulation, what you do. So looking at in terms of the rainfall history in here, as I said, in Durban, we looked at the rainfall data which has been collected in Mount Edgecombe. That's what we have closer to the airport. So you can see that we observed 307.4 millimeter of rain on that day, on that location, especially there. So this is just to give you that the meteosat image of the infrared and also the precipitation at the ground level. And this rain occurred, unfortunately, during the evening hours, late evening. It started around like 8 or 7:30 in the evening until to the morning. In fact, even myself have lost a big wall has been collapsed. So I was not known. I were there in Cape Town, and then I received a phone call. This wall has fallen down. So you can imagine that it's the depth of that rainfall within 8 to 9 hours, which can collapse whole things. Okay, so looking at in terms of the different atmospheric parameters, what you see here is the relative humidity on the in our left-hand side, whereas on the right-hand side, we're looking at the vertical velocities. I hope you people know that those terms, which will be more practical to be used. So we have very strong relative humidity, so that is expected during the heavy rainfall. That shows exactly why we have such depth of rain which has been occurred. On the other side, you see, as I told you in the beginning of my slide, so one side of the South Africa where we have a lot of water, and the other side of the South Africa where you have drought. So that's the exact situation where you see the vertical velocity will give updraft and downdraft of the air movement or the parcel movement, where you see that very higher situation of the updraft, where that rainfall, which is heavier over in the Durban regions, but in the other side of the region, where you have a less rainfall or no much water there. And here we looked at the potential vorticities. People, you know what is the potential vorticities. We will be taking the potential temperatures and then in relation with pressure, humidity, and temperatures and the wind, U, V, W. U stand for zonal wind, V stand for meridional wind, W, which as I said, omega, that's what called vertical velocity. So we take into account and then see the forces of the atmosphere to bring the convection situation into the location. So that's what you see under dramatic situations at different height levels. So you can see by the lower height levels, which we have looked at, is a 250 hectopascal and 300 hectopascal, where you can see it's bringing large amount of the parcel, air parcel moving across into Durban. So that was even caused major heavy rainfall to be occurred in that place. People who are in the atmospheric situation, we call this as called cutoff low. That's what we call it as to bring more rain in terms of the dynamics of the situation there. Okay, in the summary that I just put together, what happened, as I said, more details if you want to find, you can find it in the articles. We will be happy to share. Even Vetri might share the book if people are interested and if there is no issue on that. But you will be able to identify different atmospheric situation cost rather than actual situation. So we're just looking at, as I said, we are looking at the atmospheric perspectives, whether the atmosphere has influenced this kind of a heavy rainfall. As I said, we also looked at it into different objective of the atmospheric situation, like extreme condition. We also published recently, I'm not against to COVID, but we did the COVID-19, you know, in South Africa. It was like third wave of the COVID, which was a dramatic. We lost about 38,000 people positive. So we looked at it again during that particular week of the COVID spread. We looked at it, what was atmospheric situation which has favored for this to be spread across. And then we published that as well. So in case if you are interested, you are more than welcome to contact me. I can able to give that. Okay, so as I said, we are also a student from here, University of Zululand. We used to hear the rainfall data collected from South African Weather Service. This is a long-term series of data, like 30 to 40 years. And then we are trying to use the machine learning to decompose the signal, identify different component of the signal, and then to see whether we can forecast that situation later on there. So just to see that how we do it from the time series of the data, we apply FFT, that's a Fourier transform. But if you do Fourier transform, you will get only the time domain. But if you want to also to locate what time or what particular period it has been happened, then we will use the wavelet analysis. So here we use the different components. So what will happen there, from left to down, you have a different mode of intrinsic mode. That means to identify from the highest mode to the lowest mode. So what is the highest mode? The highest mode means how quick it can occur. The lowest mode means how longer term it will happen. Means from whether it can occur in minutes to hours or it can occur in decades. So that's the meaning of that. So when you decompose the signal, you will be able to identify which component is dominant. So from this, we will say, if there are component is dominant, then we can say that this happens like every 2 years or every 3 years or every decade, or so that you can be able to analyze and then come to some kind of forecasting later. So on this study, you know that again, the precipitations is more linked to aerosols and cloud. So here we looked at it not only South Africa, but looking in the African region until to the Central Africa, where we classified into 3 or 4 different regions. And then we used here El Nino and ENSO, and then identify whether that contribution of El Nino and ENSO on the rainfall and precipitation, and mainly looking at the aerosols and cloud, how does it mean interacting each other there to enhance the rainfall in the location. And we also have a small simple model, which we will be using it. So we have done, again, used with the atmospheric South African Weather Service. We looked at the temperatures, which I'm presenting here. We also did with the rainfall, but it was not working very well. So to be honest, because the rainfall has a large amount of contributions, it's not only a different oscillation or different forces, which you've been using here. So it could be different, but need to be moderated. But the idea here is, if you are physics or mathematics, you know that y equal to mx plus c, right? Y is the value which you get, it depends on x, where m is the slope and c is what we call the residual. So what we did that instead of having m and x, so we developed that equation into large. So what you see, the m, which is nothing but the coefficients like C1, C2, C3, C4, C5. So those are the different parameters, what we call the constants, which you need to be derived. And then, whereas the x is the variable which is dependent. So here we use a different kind of oscillation that includes semi-annual oscillation, annual oscillation, quasi-biennial oscillation, ENSO, sunspot number. And then here in South African region, we use the Indian Ocean dipole. You know that because we have 2 different oceans here, Indian Ocean and Pacific Ocean, to identify whether Agulhas current, which will bring any influence on to the atmospheric parameters. So you can see there is a measured one that's in blue. And when we simulated keeping all these parameters, we could able to see more than 90%, we could able to come into the measurement situation. So that means to say the model work to simulate. So we can generate for another 100 years what will happen as well. The beauty of the model is to, again, break down in terms of the components, and then we can able to identify exact contribution of these forces. As you expected in the annual oscillation is expected in the temperature. So that's why we have a maximum contribution that's about 71%. We also do get some kind of negative contribution. That means this parameter is not heavily contributing that. So you need to remove it. Then you will be your values may be increases as well. So that can be made available as well. Okay, so that's another situation we did. This is again, as I said, when we have a large flood, we also observe cutoff lows. So this is one of the event we reported, the cutoff low, which is occurred in winter 2015. As I said, we are also looking at here the stratospheric ozone coming down to the troposphere during the time of cutoff low, where that time the tropopause will break because it will get weakened, and then it bring the ozone concentration from stratosphere to down into the ground. So that's what we call as a stratospheric intrusion. Okay, so there is a website. We are happy to browse around. As I said, it's not get updated because we had a small issues with our building. We had a fire 2 years ago. They are still renovating. So, but we just made that server is available now. So where we have our website where you can able to get most information. So it's atmres.uksden.ac.za. As I said, we will post a number of training workshop and all those things, including data, it will be available through the server. Okay, so these are some training education program which we did so far. The last one we did recently between 18th and 19th of September. That's part of the machine learning and numerical methods, which has been used in the atmospheric science. Okay, this is one of the workshop. Maybe you may have some colleagues from here, from University of Zululand, also participated here. Okay, so these are our recent publications. If you come across sometime, you are more than welcome. Colleagues, that the second article is from China. We'll be collaborating with Zhejiang University as well. With that, I will thank our collaborators nationally, internationally, and funding people so far with the group. Yeah, otherwise, I keep our Chinese people to visit some of our colleagues, our land, and also our natural big fives, if you can make it. Thank you.
Thank you, Professor Shiva. Really, it's very interesting, this presentation. Everybody knows in South Africa what happened in 2022, the disaster, heavy rainfall. But also, I believe, yeah, you have a good heart. I believe, I don't think you can take it back, that sensor to your office. I hope you are going to live here. Okay, but also I want, I can start from the first question, maybe. That the predictions, I think I know you are expert in the atmospheric science, the prediction of the weather forecast. Why is there any, why it's not accurate? The 2022, the heavy rainfall also, how we fail to predict that heavy rainfalls? Because so many research is going in around the country, but also today also the 100% rain, but I think morning it was drizzling. But is there any the research aspect or something, the data when you are obtaining from the satellite, or is there any issues?
Yeah, so that's a good question, because that's why our interested to look at the extreme condition of the thing, because this was the extreme conditions. So normally, people are able to predict if it is at like a lower region or lower time scale. So as I said, in this flood, we had a similar flood in 1987, and no one has been expected that it will happen in 2022, because like about now we have 35 or 40 years if back is coming into that. So if that, if you look at in terms of the numerical method which I have shown, so we need like a very large quantity of the data to identify that mode of oscillations, because oscillating like every 40 years or 35 years. So if we want to identify that kind of mode of oscillation, then we need at least 2 times of the data what is required to forecast such situation. So that's the one reason why it might be failed, because we don't have that kind of quantity of the data. And then other reason that, you know, as I said, there is a lack of measurements in the continent, because, you know, though we are forecasting, though you're trying to forecast, but it's all depend on the input measurements what you have given. So if you don't have the measurements in different locations on the different time period, so it will fail because it doesn't have actual measurements to forecast into the future. So again, the measurements will fail here as well. Currently, I think what we are using, even at South African Weather Service, we are using ECMWF data for the forecasting and stuff. My colleagues from he was there in CSIR, and then he also moved to South African Weather Service. We tried to do the rainfall with Francois Engelbreg and also William Landman. I'm not sure if people know that. And there is now Mary Jan. She moved down to Sewon. So they were worked on to create a local model for the rainfall. I don't know the status now, but there is a Water Research Commissions which is looking at to see how we can able to forecast in the future for the South Africa, or how to improve this model to bring into that situation. But again, as I said, the extreme situations we may not be able to get into it, but at least for 3 to 5 years scale, that should be available. So it means to identify if anything happens in next 3 to 5 years may be suitable because of the data availability for 20, 30 years. But if you need to have anything beyond 30 years to forecast any event, then we need to have another 100 years of data or something like that. So if you have a large quantity of data, and then your accuracy is too high. If you have less number of data points, and then your forecasting will be failure.
Thank you, Professor. Also, I hope all our students will contact you for getting more data training from you. So, colleagues,
Thanks, Ram. Very interesting talk. What's the effect of stratospheric injection during the cutoff flow? What does it do to the weather?
What's your question?
The stratospheric injection, when you have a cutoff flow, what does that impact? How does it impact on the weather conditions?
Okay, so it doesn't, we didn't look at in terms of weather conditions, but what will happen that it's like an exchange process in the atmosphere from stratosphere to troposphere. So literally what happened that, we say that the mass has to be conserved. Again, I'm physics person, so I will talk always about physics. Okay, so the energy has to be conserved and the air mass to be conserved. So what will happen literally in atmospheric situation, if stratosphere bringing the ozone down to the ground, it will take the water vapor content from the troposphere to reach into the stratosphere height. So there is an exchange of those water vapor and ozones which is moving there. So that was the cause which will happen. And as I said, during this cutoff flow, most of the case, it will break the wall between troposphere and stratosphere. That's what we call as a tropopause. Will be weakened. And that was happened that to bring the ozone to bring it down. So when the ozone comes from stratosphere to troposphere, then it will act as a pollutant, of course. And then the other time, we are taking this water from the ground, this water moving up into the stratospheric regions. So as that's what my question as well, because we also have in the stratospheric region, we have sulfur dioxide emissions to have. And this water goes up, that will form as a sulfuric acid. And then it will be returned back as a rain, as an acidic rain. So we also looked at it that in two different cases, the one which we had volcanic eruptions. During volcanic eruptions, we have a lot of sulfur dioxide injection into the atmosphere. So that's how we've been looking at. So as I said, in short, we are not looking at the weather parameters, but we are looking at in terms of the concentrations in the atmosphere. How does it expand?
You showed pictures of the dichotomy between the west coast, the west and the east of Southern Africa, where you have drought conditions, bad conditions, and humid conditions. The driving force in the east, when you have extreme conditions, are things like outdoors. Do they couple and are they supplemented by convection in the west and the southward movement of the IPC? Are those all interrelated when that happens?
Yes, it's 100% true that, because most of the time what we expecting is the Indian Ocean region, which has been affected more strongly. That is also due to the passage of the ITZZ cutoff flow and everything. And since Durban is, or KZN is located in the such region where we have influence of Indian Ocean coming across. So our next topic, which we are going to work next year, is between the canal between Indian Ocean, the South African border and Madagascar border. And then looking at that canal between the two, and then see there is any influence from that canal to influence over the KZN region. So that's a topic we now working on it. And there's also to include some meteor radars. So we will be tapping into South African Weather Service to move the radar to focus on that region of it. And then we also have in Madagascar, we want to put one meteor radar, and there is a one could be in Reunion. And then looking at all the three radars into that canal when we have expected heavy rainfalls and stuff. So that will give some kind of answer.
Okay. Yeah. Yeah.
Thanks for a wonderful presentation.
You made mention of the unforeseen events, the known unknowns in terms of prediction of rainfall. From a hydrologic perspective, I think we all know that rainfall is quite important. What kind of advice would you recommend as part of mitigation measures, particularly when it comes to planning of infrastructure to prevent such losses in terms of life as well as resources?
Yeah,
Do you
so
speak to design rainfall depths as traditional methods that are used, or what can you?
yeah, well, that was now we are working together with the CINI for one of our master degree students to looking at all the surface level in South Africa. You know that the one is the rainwater which is passing through, but you will degrade that your surface. So when the surface is degraded, so then we have like the big holes which has been created, or even that your building get collapsed, because you know that it's irrigating the surface region there. So we're looking at what are the vulnerable places where you have, if you have a lot of flood, if the people are living in the vulnerable place, it has to be moved away, at least to be planned in the future. They should not have any construction of buildings or the land use in that place for the people to be lived. So we are looking at that kind of things to see whether we can able to get into access to those places. And of course, you know, if you want to go into business, it will be interesting for the insurance people. Because tomorrow the insurance people can come back and say, you built the house where you expected you have a large amount of flood to be occurred, and then that's a building collapse. So they maybe even decline your insurance to say that you are not supposed to build it there in the first point. So it will be interesting to see, but we will look at it all these factors. So that's what we want to situation analysis to do in different places, because that 2022 flood will give more details of that, because we have a lot of pictures, a lot of places where we identified where the water was being stored long, or where the dam has been break, and also, you know, the bridges has been collapsed. So where we're going to see that situation and identify whether it is really occurred due to the flood or it's been occurred due to the age of the things. So that will give some kind of answer for future management.
One last question. The recent flooding that we had in 2022, is it related to the same maybe historical periods as the ones that were in 86, or it could be as a result of the human activities that are somehow affecting the atmospheric activity processes?
Well, I think that to be in the 1987, which is occurred, it's occurred a period of days. It's not occurred just in one night. Whereas this one in 2022, which is occurred overnight, nighttime periods. So again, the period of the rainfall is different between the two cases. So as I said in the with the other questions, it has been have a long period of a gap, because it's looking at like 30 to 40 years occurrence. So that's why we can't able to predict it, because even South African Weather Service released warning notice, but they have not expected this will be this high. So I can't say that are 100% sure that it could not be relevant to human activities or things, but it could be a natural disaster or natural activities to bringing some air parcels from different situations. That's why we looked at it, the atmospheric dynamics part of it, how it blends. So there is a lot of forces which is bringing out air parcels from different locations and bringing across into the Durban region. So,
thank you. Look, I think the last question, bro.
And then it's like related to what has been said before, but it doesn't just know from your opinion, that can be the way out, because we know this event. But I think we can predict the rest of it, and likely to attend the what can we do so that these people are prepared and so that it can be impacted them?
yes, so that's what I say, that our plan is now to locate different vulnerable places where you have different loss of buildings, different loss of people, different situations, including, as I said, the different roadways, railways, whatever it's been damaged, to look at why it is being caused. Is it caused due to the flood or due to different situation? And that gives some kind of input to have some future plan to address into the government and then to provide some input.
And lastly, you talked about the which capacity like that, because you get to know the time scale, you cover both historic, present, and in the future. That you have access to.
Yeah, so the one what we did with using a historical rainfall data, so we know that the El Nino ENSO occurs, so that we know like how many periods it will occur and where it will occur. So that's what we located in terms of different regional until to Central Africa.
So you have access to all that, and you should have that.
Yes.
You have for all time states. I mean, historic, present, and future. So in case one gives to you that.
Yes, so you're more than welcome to use it. But as I said, what normally we do, I don't want to give somebody's data to someone.
Yeah.
So we just to inform you that what are the conditions they have informed us. So just to follow the same conditions, because I don't want to be caught by releasing someone data. So, but we just to follow them. And that's what I did, I told you with the NASA when we are downloading the data. So we followed their terms. And then they agreed for me to give the data because we have that connectivity and bandwidth problem to download huge amount of the data. So that is possible. Even we have ECMWF data, high resolution data, for more than 30 to 40 years. If you need to use it, we have it like in terabytes of hard drives.
Okay, thank you so much, Professor. Okay, thanks for your presentation. Really, wonderful. Colleagues, I think the time for break 15 minutes. Okay, please we need to start the session at maybe 11:20. Is it okay? 11:20. I can do it. Yeah, I think it's possible. You can really wait everyone, please. No problem. The tea and coffee is very snack you can eat.
Lee.
Okay. Now they can see on the live.
Yeah.
That's good. I think Hi, yeah, how are you? Can you speak to Jacqueline? You are speaking with Vijay. Yeah, you're speaking with Vijay. Can you speak to Jacqueline? Jacqueline is there. Hello? Jacqueline is there. Five, 040. Okay. 520. 089.
Yeah.
The control it is. Bluetooth. Yeah. There was one way it was. Can we use this one? Yeah, it's supposed to, but then it's okay. Then it's okay.
Colleagues, I think session 2 will start now. The first presentation for session 2. I would like to invite Professor Takasani Kanyari from University of Western Cape.
It's right hand on here, very sophisticated. Is it flash drive? I think so, yes, the first one. Information.
Am I connected? I'm seeing myself on the screen. I need to wash my hands. 30 minutes. 30 minutes. Yeah. We'll delay to connect. Somebody is difficult to connect this. This is too already connected. Maybe it will take few minutes. Open that. Is different. There is so screen. Screen. This one is here. There we go. Still good morning, colleagues. We have done with the technology issue. The presentation is really participatory, but there is a dead silence from the right. I think we need to participate more. My name is Tokozani from University of Western Cape. We would be talking about the showcasing the science, technology, engineering, and management of groundwater. I come from the Groundwater Institution, and that's what I'll be talking about. And below there, the flag sheets, you could see the partners that we work with. So it's very participatory in nature. Those are the people that are the center. So acknowledgements. The one highlighted in yellow, that's me presenting. But we have a team of people at the University of Western Cape for the groundwater part. So if my colleague Yongshun Xu from Northwest China, focusing on groundwater modeling. And then myself, I focus on environmental hydrogeology and hydraulics, and the recharge, discharge, and field hydrogeology. And Prof. Nebo is on water management and modeling. And then you have Smeya Clark from hydrogeochemistry, and the Kevin Peterson groundwater governance, and Jackie, our citizen scientist in the group, and Prof. Revin from California at eco-hydrogeology and the hydrogeophysics. That's how interested listening to the topic on the physics. And then all the colleagues from the surface water team contributing to our research part. Just for a little bit of marketing of myself, I have my academic career, PhD in hydrogeology. And then again, medical geography and medical geology in the Norwegian University of Science and Technology in Norway. And then my master's and first degree from University of Malawi. I am a Malawian, very proud of being Malawian, born and bred. But again, very good to work in South African environment in SADC. So that's my position at the University of Western Cape. From last year, I'm the Deputy Director for UNESCO Chair on Groundwater. And then in the department, I do a lot of academic coordination for the students. Currently, I have 25 PhD students, a little bit red flagged. So we are tackling that next week in the faculty that I need to come down I'm not very sure of taking other students in 2020 next year. But then I think 8 of the 25, they have submitted intention to submit. So they should be graduating in April, if not September, then I can come back. I need to be operating between 15 masters and 15 PhD. That's better. Above that one, it is a bit hectic. In terms of projects, currently I'm working with the enhancing sustainable groundwater utilization in South Africa, and this project is in Polokwane, Limpopo, and managed aquifer recharge in Polokwane and the Northwest. Groundwater resource directed measures, that's a water research based projects. And the spring project, again, water research funded, and have 2 NRF funded projects. And then we have Africa Union, which we call the S Water 1. We finished completely 2, and now we're on the 3rd one. And I have 2 projects running with the petroleum, South African Petroleum Agency. That's groundwater monitoring. Our focus really is strengthening human capacity. We call it from hope to action, and that's through training. We focus on partnerships and collaborations and networking and co-funding. So colleagues seated in this room would want to engage more. I call this marketing slide so that we know where we are and from which angle we are in. We are more focusing on the 9 challenges if you are in the water sector, especially groundwater, Africa as a continent. Those are the 9 challenges that we are trying to address, the 2016 agenda in the water sector, and we are all doing research towards contributing knowledge to solving those challenges that we have. And our focus is the training should be towards that. Groundwater, surface water interaction recharge is our basic, very fundamental. If you look at the slide, this is what we focus. So we tend to be toned down. If you're a groundwater person, you must respect surface water people. If you're surface water people, you must respect groundwater people because of that interaction. So your water is water. You call it depending where it is. So the relationship between your water and vegetation and water wetlands and water and soils becomes very critical. As a scientist, you tone a little bit down if you're aware about the interaction, about recharge and discharge from that angle. So we'll be showcasing, I think, the presentation to showcase what we do in this part of the work. Our first case study is groundwater recharge. We are using wastewater-based epidemiology to improve water security, and this study is taking place in the city of Cape Town, Cape Flat Aquifer. We are focused on groundwater remediation and the managed aquifer recharge. I have 5 female candidates working there, 2 are PhD, 3 are masters. We are looking at the biohydrogeochemistry research with the Medical Research Council in Cape Town. Very much supportive. We sample and then they do that. The idea is to identify the pathogens in groundwater that have come from wastewater treatment plants, and we are looking at a risk assessment to the aquifer systems. For a change, I have made up my point. I think September, October, November, every Monday, I go with my students, waking up around 4 a.m. to run out the traffic because we need to do 6 wastewater sampling by 12 o'clock and another 6 in the afternoon. So 12 wastewater treatment plant that we sample every Monday for the inflows and every Wednesday for the effluents. The idea is to identify the POPs and the contaminants of emerging concerns in the water that has been treated and see the risk of getting into the aquifer system. So we're working on the aquifer storage, so a storage recharge mechanism, and that's our basic understanding of recharge and then purification and remediation. But first we need to understand the characteristics of the subsurface. So as a groundwater, people will not run away from the aquifer characterization of where our water is being stored and later on being abstracted. So that's very fundamental. Our second year module, Introduction to Groundwater, they will be emphasized on that one and do practicals and they do assessment on that until by the time they come to the 3rd year, 4th year, they need to understand the subsurface characteristics where the water is stored. So this is one of the examples where we do monitor the influent for wastewater-based epidemiology and then the effluents. The idea is to see which pathogens can be killed by the processes and with which pathogens still escape those. And from the Stellenbosch wastewater treatment plant and a few others, it has come very clear that some pathogens, especially the pharmaceuticals and all those some contaminants, they seem to escape the treatment plant and still in the discharge in the fresh water, and we use that for developing early warning systems for messages for COVID outbreaks. So we're looking at the rotavirus and some of the bacteria that in these plants. But the idea is to see our aquifers safer if the pathogens escape such a treatment plant. How vulnerable is our aquifers in that area? So we plan to conclude that by end of next year. Case study number 2, still continuing with the groundwater vulnerability. My colleague will be talking more about that one. Here, just to say that our focus here is the use of what we call specific depth sampler. So what has been happening previously, our Chinese counterpart will know that, but we have introduced the Chinese, and then IHA we also picked it up. We have been sampling generically, but now we want to sample according to a specific depth that we think the groundwater is bringing water to the ground, to the borehole, and then understand the hydrochemistry and quality on that part of strata within the subsurface. So it's a specific depth sampler that we started, and I will show the study that we have done now into that one. Yes, that's South Africa, and we operate into those catchments. So our Big River is really quite a teaching catchment. That's where we are housed as a Cape Town. Cape Town is right there. So we are in this corner. This is our Cape Flat area, and we do all this Big River water management area, as I'll be talking about. So that's the city of Cape Town, Cape Flat Aquifer, as I showed. So we could see this is how we have mapped. So we have boreholes in this stretch, we have boreholes in that stretch. In all these red spots, if you look at that, we have mapped the boreholes here, and we sample, try to understand the subsurface and how the contaminants goes into our subsurface. This is an unconfined aquifer system, and it's within the city. So our urban hydrogeology need to be understood fully before we go in the track of generalization that groundwater is safer. Safe water doesn't need treatment. It depends where you are, and it depends what is happening on the surface, and that's what we are trying to do. So yes, we have done in our city, we have Philippe area, there are farms. So within the Cape Town city, Philippe area, have all this farming again, very intensive, and we have all the vegetables being grown within the city. So yes, it is a city, but it's also a farming city, and all the hydrogeochemistry and pollutants and chemicals need to be mapped and understood and quantified in that part. And Gintamo worked in that area quite detailed in his PhD. And these are the boreholes that we see. Look at the depth to water, and a quite shallow one. And we see with that type of information, our borehole is quite prone to contamination in the city. But quantification, I mean, evidence-based study needs to do. And this is why we map the farms here, the manure and the fertilizers. We map boreholes around that. That's quite within that. And this is what we're doing. So we put boreholes. So we have the conceptual model, or hydrogeological concept or cross-section here. So we have the borehole here, the borehole here, the borehole here, and we see the red part, that's the top part, and confined system. And we try to track that in terms of what is happening to subsurface and the movement of all contaminants recharging into the subsurface system. With the look at the plume, and look at this one. We follow this one and see this is what we see at the subsurface, and this is what we see at the subsurface, and look what is being built on top, and we try to do that, and look at the borehole next to that. That's what we're monitoring, and that's what we're monitoring within that that setup. And then we have developed all the depth depending on the specific depth. So we have done all the analysis looking at that one, and we picked up this borehole here closer to Philippe, which is a problem one. If you look at the risk ranking here, this is the problem area, and this is the area again we need to monitor. So this is providing information in terms of where do we need to track, and this is the borehole right way here, and of the number, and we share this information with water affairs. Continue tracking that, and we map all the boreholes, and they try to bring them all this. Look at this one here. We identified these are the problem boreholes, the rest is fair, but at this depth, we have a problem. At that depth, we are okay. And this is all the boreholes line up from the, and this is Kairisha. If you look at it, this is informal settlement, and you have all these suburbs put on top there, and we put them together and see what is happening in our surface. This is just to show that in terms of the physiochemical and biological aspect parameter, that's what we do. It's not common in a groundwater to be talking about microbial assessment. We are very used to talking about geochemical, geochemistry, and biochemistry, but this one is less extent a little bit talking about the microbial in this stuff. And that's all the detailed information presented. And that's what's coming up. So we are trying to add in the biological aspect of what is happening in the subsurface, depending where we are. And that has gone to the Water Resource Commission guideline. Okay, this is the setup of city. That's why they have the boreholes. If you go on that one, we could see we have tried to follow. And this is it. And this borehole that we are mapping around that to see the impact of these activities on the subsurface. Case study number 3 is the groundwater education via field hydrogeology. Here, groundwater education for strengthening human capacity via practical lessons. And this is what we do on campus. So for our second year, we try to start teaching them very, very basic, teaching them there's a difference between depth to water and water level. And you don't go to the field to measure water level. You can't measure water level. What you measure is depth to water from the surface here to the meniscus here. This is what you measure in the field. And then you need to go to elevation and you subtract the two to find the water level. That science, they need to understanding from the second year. Otherwise, they think they're going to the field to measure water level. You can't measure level or water level. You compute. What you do, you measure first the depth to water and the measure elevation and then subtract the two. And then they also taught the equipment. So they're taught equipment and they're given equipment. You have 6 of them to 8 of this equipment that each one need to be practicing that this equipment measures temperature and the water and the conductivity. So that's quite education. I think that's what we're talking about. So we're teaching our young ones that they are used to do. Those of you planning to visit University of Western Cape, that's the map you do. And again, very basic, we teach our youngsters that if you're entering this campus, if you're coming by train, you go to gate 3, you'll be a train station. If you're driving, you go to gate 1. If you're coming by public transport, you go to public health, gate 2. And if you're driving, come to 4. So this map is taught in class, and then emphasized that they need to understand their campus. They're very, very basic, but it's the second year. So we want them, by the time they go to third and fourth year, they are quite aware of their own campus. So on campus, I think a little bit of showcasing, if you want to be very positive, that we are the only university in South Africa that we have boreholes on campus, and these boreholes, they are drilled in unconfined system and confined system. And this is space that we use, all the boreholes, they are here. This is the road to the airport, and this is our Senate building, and there's all campuses here. This area is for groundwater training. So we have all the boreholes here that have been drilled into different aquifer systems. And this is how it is. If you go to this, look at that one. So these boreholes, so if they are doing pumping tests, understanding the behavior of groundwater in an unconfined system, Sunday system, which is a aquifer, Cape Flat aquifer, then they need to be pumping tests in these boreholes. But if they want to understand a borehole that has been drilled in Mama's Berry, confined aquifer, a TMG, sandstone aquifer, then they need to do pumping test here and observe here. So this is what they do. If they want to understand aquifer interaction, then they need to be pumping here and observing here, or pumping here, observing here. So they do different activities in second year, third year, and honors, and masters, and PhD. So all students doing groundwater research, they need to be assisting on this pumping test all the time, so that it sinks in their practice. So this is showing the lithology of where the boreholes have been drilled. And you look at this one, you have the shell. Some shell, geologically, it was under shell. So high salinity EC is not a surprise, depending on the environmental condition. On the same university, during the drought, when we're approaching day 0, we decided to put a borehole treatment. So our remediation plant is here, our University of Western. So we have these boreholes for research. Those who come we want to understand the normal behavior of groundwater, and they do that. natural recharge and all the characteristics. This one now is for a managed aquifer recharge. So we purify, and we know that the problem is iron and manganese. So they learn how to treat borehole water from there before supply. So we have the treatment plant on campus, and they need to go there and see it. And this is why the dashboard, how it looks within the plant. So they all need to see how we abstract in these boreholes. So you can see the boreholes line up, and the whole water going up until the elastic purification. So they need to understand the purification systems on campus, and they need to be used to the dashboard and see how the water get pumped and get that. Case number 4 study is field hydrogeology. Again, human capacity, strengthening them. And this one, we go to the field now. This is our Western Cape and the Big River, the one I showed before. So this is the higher mountain. This is a mountainous area. We have moved from the city. We have done with the urban hydrogeology. Now we're going to mountainous aquifers. So we study mountainous aquifers. This is, oh no, that's not polite at all. My sincere apology. Let me switch that off. This is a upper Big River, and it's all to the sea. So we have a west coast down there, and there's a mountainous. This area politically is very important. This is the wineland district. This is where we produce the wine and sell them to European countries as a market, and therefore the quality of groundwater that produces wine must meet the quality of European water quality standards. So it's very politically invested. All research, they make sure that we do ground conservation and monitoring very well here. And then we use that as a teaching part of it. This is Big River Dam. For those of you, when you come, Prof, please visit us. You're welcome. Bring 2 or 5 of them. We want to grain white. We'll make you drunk. Just one night. This dam is the one that has been built 2007 in consideration of resource-directed measures. For those who read Chapter 4 and Chapter 3 of the National Water Act 1998. It's this one demonstrating that, to protect the water. And then it was deforested deliberately to increase or enhance the recharge in mountainous area, because a sandstone mountain, fractured mountain, high recharge, let's remove trees, thus we have more recharge to make sure that we fill the dam for water supply, among other things. And then above this dam, above this, and that's what UWC boreholes are, and it's surrounded there. This is what we have on top of that dam. So we have the fractured here, we have the structure here, geological structure here, and then we have to do the 3 UWC boreholes here, so that they lane aquifer, mountainous aquifer there, and this is the weir here for the surface water, and then we have monitoring points into that. Make sure that we understand the recharge. And deliberately recharge, there's a fractures here. So when it rains, we try to check how quick the water comes into our boreholes, transmissivity. Then we train them the science of paging, how the boreholes, why we need to page. And this is very important because we train them that when you go to working, please do not delegate the sampling to junior scientists. They will not understand that you need to page. See how the boreholes looks like with all that, and removing that water before you sample. So you don't just send anyone to sample, because garbage in, garbage out, you need to know what you're sampling for. So we teach that one, and then they do that. We also teach them about the, now this is really bad. Why is it not refusing to switch off? Space. Good morning, Prof. Switch them off. Yeah, look at this, colleagues. I think this is very important to share. Look at the construction of boreholes. So these young people, they understand that construction of the borehole is not metallic. We have this plastic, but we don't call it pipe. It's not engineering. We call it piezometer. I mean, it sounds groundwater. A little bit confusing. It's a plastic pipe, and then look at this. This is what we call a skin effect. This is not natural geology. The hole was drilled, the pipe was done, and this is a grouting here. You gravel pack. So when you grab, it's a Z. The password is Z. You gravel pack here, and then so whatever you're measuring here, you should take care of that. So they seem to be knowing that and being that. So our students go to the field and they do that. They're also shown the pumps, sampling pumps in the field, understanding sampling pumps, practical demonstration. Our technician is in there. This is one of our master students. The technician is observing, giving instruction, telling him to test. The idea that after your 2-3 years of masters, you have also mastered the way the sampling is. That's our famous Mr. D, specifically hired as a technical person to manage the groundwater activities. So we seem to be very much interested in the groundwater activities. Of course, we have a bucket, we have 2 vehicles just for field work. And look, this is one now they go into calculation. At what point do you want to sample? If you're sending to the field, they can use a mathematical approach or they can use the chemical approach. So if they're using chemistry approach, you're saying 3 parameters must stabilize, or they can calculate 3 volumes, paging to remove the standing water in the boreholes before sampling. My point here is you don't just send anyone to get groundwater sample for you if they don't know at what point they should see sampling for that borehole. You might run into problems. Again, we work with the partners. SSR is one of my big partners, so they bring that equipment. So we all go to the field, and field hydrology. They go to the field, they teach students how to sample, and then all we are in there and all doing the work. This is my favorite Maralo, which Prof. Resho knows. And then we work there. The CSR people demonstrating equipment, carrying students and asking them to do in the field, training them how to do the work. And all this CSR, this is just training how to sample. If you're sampling surface water, we know the basics. You don't sample in the edge. Your water in the edge, in the bank of the river is quite slow down. It doesn't represent the quality of that water. You sample in the middle of the when the water is running. And that science they need to know. Young people may not sample here. They're going to stand here and then take sample for you. And if you are paying them less, it's worse. And then you could see, we are talking about microbes here. They need filtering, you sample for microbes, you need to be trained. These young people need to be trained. This is Bettina, for those of you from CSR. This is Professor Paul Obohosta, with the current Dean of University of Free State. When he was in Western Cape, we go together in the field, training people how to sample, and then all doing the field analysis. And that's what we do. We are talking about groundwater for capacity development. And these are 3rd-year students taking the field, and they're telling them how to filter for chemistry, and then they go into that. Of course, at night, if you have worked with students, then buy meat. Let them braai. They enjoy this. It's the culture of our university, the culture of Western Cape. No one joins there and disrupt this. They go to the field, you make sure that at the end, they should braai. And the trick is, the solution is, Prof, just give them money. They will tell you how much, because they'll keep change and buy uchwala for themselves. So you don't interfere with them. Let them braai on their own. Just make sure that they wake up afresh tomorrow. The last study, the case study, is again on practicals, and this is now in the Kepa Gallas, colleague Prof from UKZ, and you presented on the physics on Kepa Gallas. We are settled very much in Kepa. This is Western Cape, again, this is Provi, and we're here, so working this catchment in Kepa Gallas. That's the coastal aquifers. So we're moving from mountainous aquifers to coastal aquifers to urban aquifers to have that a little bit of set or complete. And this is our monitoring network that we have. This is our 4-flay, so 4-flay, and the student flay in the Kepa Gallas catchment that we have, and look at our fault lines, our geological strata there. So we try to understand the groundwater that in, and this is a paleo environment. All this area was under sea in those areas. So we try to understand the movement of groundwater here, and we have groundwater here, and we found that 4 meters here in the subsurface, so water will not flush to the sea. It's already in the sea. And then, okay, they do cross sections, and that would have and all the boreholes trying to put there, and then trying to showcase that. Now, what we have come to now, we are doing a confined system and confined system because we think monitoring should not be generic. So the current science for groundwater recharge and monitoring, when we are talking about monitoring, the question that will not be surprised, that's what we are sharing here. When you present monitoring groundwater, we will ask you as a groundwater people, the data you're talking about monitoring, from which aquifer system did you monitor? And you say, oh, groundwater generally, all KwaZulu-Natal. Oh, so all KwaZulu-Natal has one aquifer system. Is the aquifer system confined or not confined? Are you monitoring genetically, or you want to understand what is happening in a confined system and what's happening there? That sense what we're pushing now. So we do aquifer delineation first and try to see which boreholes are tapping from which aquifer system and what is the quality of water in both the system and which water should we allocate not allocate for a DWS, Department of Water and Sanitation. So I have a good strength from Council of Geosciences. So we do all these geological structures. We have all the geology data in our database so that we can know that these boreholes, they are tapping in this type of aquifers, and this boreholes is unconfined aquifer, and then we can do the measurement. And then the drills, we have drilling logs, so we understand in which boreholes how deep is and what is the geological stratum in each of the boreholes that we do. So quite a lot of teaching, and look at what comes out. So one you say all the boreholes in catchment, and then we see, okay, this borehole, you take the borehole number and get to the driller, get how deep is, go number, go to the driller and put on sketch so that you can confidently say that this borehole was drilled in this aquifer, therefore where the screen, we need to put a screen. So going to the next step is to put at what screen do you getting water from that? Still the same area we have. And of course, we do there and do the field work ourselves. I was very small. That was 2013, so I was still very young. There was no gray hair, but now it's come. Don't worry. You reach there, some of you. Okay, and then we hire a geophysics. So we have geophysics private, pay him. Is in Western Cape, the cheapest, Martin. He charges, I think, 9,000 Rand a day. So you need to make sure that no more than 10 days in the field or 5 days. That's his rate. He can't go more than that. Normally, the majority they go 15,000 Rand a day. Yes, your physics. They set up the equipment like this. They train students. They correct data. They go in the evening, download the data, provide the interpretation. But we want that type of training for a week. I think it's good for enhancement. Look, okay, now he's eating here, so you get tired also and eat. And then you see all our students, they can get, so by 7 days in the field, they tend to know what that instrument is. It's important to know how to work with the equipment. Of course, we have our UWC visibility vets, which they keep on missing every year, and I keep on buying 50, and every year they are 50. You ask students, they are 50. Even if you bought another 50 next year, they'll tell you only 50. Then drilling, they also learn drilling. This is my colleagues, Dr. Yakunel, now is in Australia, some of know, and then a private drill again. Now here we train students how to drill the boreholes. So they must be on the site, we must be with them, and we do the work. Of course, you need to pay them, that's fine. This is working with the communities. So the farmers in this part of Cape Agalas, the structure is very established. For those of you South African colleagues from China, here we don't mess up with the structures. Here, the upper part is all white people, farmers. The middle part is colored, the black is down. You need to maintain that structure and operate within established structures to be accepted. And it works very good. And so we work with them, and we work very well in the air. Those structures, they tend to help. Our student that has one, you could see here, when they go to the field, technicians do supervise. So they put on mixing up, putting rain gauge. So here they're putting rain gauge, SIM and all three of them, and putting rain gauge and work with the rain gauge. They need to put up the rain gauge themselves. And of course, you also bring the social scientist. They're also good, but these ones normally, they like check on their phones. So if you're checking on your phone here, you're in that category. Right, this is the last one. The up in Limpopo now, we're looking at natural recharge and the managed aquifer recharge. We are groundwater center, so very much understanding what comes into the system and what gets out of the system in groundwater. And then we have one feasibility study and one operational one in up north. Those are the partners. So looking at the groundwater monitoring in hot catchment in Limpopo, and the one in northwest. And this is the Limpopo, we operate in this. So we have this side, this side, this side, and then we start with the geology, it's groundwater or hydrogeology, water in the rocks, so that will not escape to understand that. And yes, we check our boreholes, get structured, and we move in the farms. Again, here we have also a very good network with farmers up north, and they tend to help a lot. You go through Farmers Union, and the chairman of Farmers Union is in our team. So each time we go there, say, can we meet farmers? Which date? They give you the calendar, you book flight according to their meetings, and then you work with them. And you get all the data that you want, by the way. Very nice one. These are some of the equipment that we have shown that we use to train. So I'm talking about groundwater from human capacity. Back to the problems. These are the problems. So whatever science we are trying to do in groundwater, we try to be providing information that can be used to develop intervention to address the 9 challenges that we face in Africa. And this is the 2063 challenge that has been identified in the water sector that we all need to be moving towards providing solution to that. Few publication, hydrogeophysics is our interest. A prof at UKZN I saw your email. I'll be knocking at your door. We need to intensify collaboration on hydrogeophysics, which we have done too. So the papers and the other paper is in process that we should be complete. Otherwise, thank you for listening. And this is some of the students focusing on the groundwater discharge group. There are, I think, 20 or 30 of them. Thank you so much for listening. And I will not take questions. I will take comments. So please comment. Just comments. Tell me how to do better. Don't ask me questions. Tell me how to do better.
Thank you, Dr. Thanks for the invitation to also, already we done some what's happening in there? Are we running ready to submit? But we will try to come back to you for some further research collaborations. Colleagues, any comments? Yeah.
Thank you. It was very interesting.
Do I need to be
I'm not asking questions.
Exactly. Yes.
How you are managing it, because most of the university nowadays moving across into practical component of education. So I appreciate what you are doing there in University of Western Cape. So my question is that how you tap into it? Either this, whatever the field work you do, does it come as a practical component of their education, or it's a part of, like the research work?
Money-wise.
Or how it is incorporated in my education?
For the undergraduate students, year 1 and year 2, year 3, we have annual budget of 500,000 rand for their practicals. So that is not negotiable. But in addition to that, the research capacity, our university takes 20% of the research grant if you bring in research. So one of the things that I've done, I haven't been at University of Western Cape for a long time. It's for 2008 to now. So maybe 10. So what I have done is to negotiate with the research office. Say, this 20% that university is taking, where are you putting this money? They said, go into the tutoring part in the bigger basket. And say, wait a minute, can you motivate, I want to buy this equipment, and you as the university donate this 20% to my project in terms of equipment instead of you taking to the VC. Would that be possible? So some it works. I mean, if you have a 10 million project, 20% of that one, you take that one, you put to the research. So it's about negotiation. And again, you use your HR, which we don't claim, you can also factor in this. But it's small. And then I think for the past 5 years, we had a private funder. They refused to disclose their source, but they donated 18 million rand towards Kepa Galas catchment instrumentation. So most of the instrumentation that we did during the boreholes, putting piezometers and rain gauge, it came from the 18 million rand that they gave us. And they made sure that it's used on research, no payment for that, apart from students who can get bursaries from there.
No, my question is that from first year to third year, it doesn't, in South Africa, you have a class mark and the examination mark. So I'm asking that whether the part of the work which a student do in the field that go as a practical component.
Yes, that's assessment. Yeah. When you take them to the field, so if you are going to stay with them for 1 week, what they do in the evening, during the day, in the evening, they do analysis and write report, and they must submit report while in the field, so that those who have created whatever reasons for not coming, then they don't access that. So there will always be students who seek and whatever, but say, sorry, this practical was a field work has been assessed in the field. It will come next year because we're not closing university this year. So you can come back next year and do the same practical.
I think you will consider that practical as a mark.
Yes, it goes towards the assessment. Otherwise, if you don't do marks, you know the story. Anything you must attach marks. Then you get the collaboration and the participation. Otherwise, free activities, they all get sick.
Thank you.
Yes, yeah. Any more comments?
Yes,
now, yes, bro.
It's not location, just something to consider. I don't know, maybe you have an answer to it, maybe it's not.
No, I don't have.
The issue of making contaminants. mentioned that we escape from the treatment plants and the surface water and into the rivers actually. So it means that they end up into our drinking water treatment plants.
Yeah.
So I was just thinking about the issue of considering how they can be removed through the water treatment processes. Any studies you are aware of the limit on that?
I have tried to recruit a postdoc, Tapiwa Hetwayo, to remediate that. But what we are now with the Medical Research Council, we want to see how much comes into the plant and then assess the effectiveness of the plant, how much the plant can remove, remediate, and see which contaminants escape the plant and how many are there and what can be done to this before they are discharged. Somehow that one. I try to. Yes.
I remember Professor 2018. I think there is zero when they announced the local the government, Western Cape state government, provincial government, they announced different recovery plans for controlling the water crisis issues because you know the day zero was
it was.
that time one of the recovery plan is artificial recharge into the aquifer from the treatment water plant. Just I want to, I'm very curious to know whether that plan was implemented or still anywhere is working on the just treatment water, after treated water, they are going because you know the Cape flat is a more salinity, the groundwater. They can't use the concept of that. They want to dilute the groundwater during the artificial recharge.
Yeah.
So is there anywhere they're doing that?
The plan has continued. It's in Philippe area, in Cape Flat Aquifer, we have a new managed aquifer recharge plant. But what they have done, the Atlantis one, which is 40 years old, they've also expanded. And the one I was talking about, managed aquifer in Langaban, we're also doing a study on feasibility of having another plant. So we're likely to have 3 of the managed aquifer plant in Western Cape. But they also went ahead adding the desalination part. So there's also desalination. I think there are 2 plants that opened that time to make sure that we address the day zero problem. But when it was put off, then the cost came in, and then but these 3, these 2 are operational at the moment. So yes, the plans are there.
Thank you, Professor.
Yes, sir. Oh, okay. There's one. Yes, I noted that one. Okay, let me say. He always takes your question, don't worry.
Because the Western Cape there's some stress. So I want to ask you whether you guys have been doing that. And then the second one, in terms of data sharing, I've seen that you guys are doing quite a lot of commentary in the guys of the Western Cape, but there's some gaps. Actually, the Western Cape is one of the worst people when it comes to commentary. You guys are doing such a wonderful job. Are you guys sharing the information?
We are not sharing information for free.
The equipment is
what they have done is to engage or strengthen the collaboration. So from the groundwater part from last year, I think they have included me in their planning council, the MIT, for the water supply system, what they call it, from the groundwater perspective. So the idea is to bring all institutions. Your observation is very true, that sometimes we continue working in silos. So you find the municipality, they have their own boreholes, and then the farmers, they have their own boreholes, and then the DWS, their own boreholes in terms of monitoring and checking. And then we have Schedule 1, all the household, their own boreholes, but by the Schedule 1 in National Water Act, you can't access, you cannot monitor levels or quality of the boreholes behind somebody's yard if that law will be infected. So legally, we are prevented from knowing the quality and the quantity of groundwater in somebody's borehole because of Schedule 1 rule. But again, it's only the your water location, the general authorization that you can know the quantity. So there are same things that are working on. So what they have done is to bring all these departments together and say, bring your data to do that. That's the governance aspect. So it's a challenge, but they're working towards it. They call it harmonization of groundwater or water database. That's a very good observation.
I have one question, maybe because when you say about zero water, so we had a situation with the government to take the ocean after to be converted to drinking purpose.
Mm.
So what was that situation? That have you analyzed any Indian Ocean or Pacific Ocean water and come up with any situations during that time, or it's been...
We didn't analyze the suggestion. I think what the nation took the position was we can't close institutions because of day zero. And I remember 2017, that's why UWC, I showed the borehole there. That was one of the solutions, that we're not closing university because of day zero. We are sitting on Cape Flat Aquifer. We need to have boreholes on that campus and supply the water. Now the question was, what about the general population? How do we deal with that one? So that's where they went to one option was restriction. So there was a number of liters, reduce the pressure. This is the amount of water I can get, because dam water in the dam is low. Oh, that's pressure engineering, you know. So that was one intervention. The second one, let's go desalination. Let's desalinate, and there were all companies, I think Denmark came, whatever came, let's desalinate, remove the salts and make water to a potable level that you can. Third option was the managed aquifer recharge. Let's collect all what we use, put in the subsurface, abstract it, a little bit of treatment and supply. So those two options were running parallel to that one. And then the fine that if you are found washing a car, washing this, doing this, the penalty should be a little bit higher to make sure that you pay for it. And Constantia, one of the richest suburbs, was one of picked up because they're saying we can pay. It's okay. If you can pay, then you need to, the fine need to be higher so that you stop using the water. So there were all interventions that put in place, but now they were toned down when the situation returned to normal sort of.
Thank you, Professor. I think we are running out of time.
Yes, hey, you quizzed. And if this was my defense, I think I would have passed.
Okay, I think I would like to invite Professor Kao from Shanghai University, China. I would like to review that presentation.
Yeah.
Hello, everyone. Thanks very much for Professor Vetri's invitation. It is my pleasure to have an opportunity to present my study here. The topic is hydrogeochemical characteristics and the processes of groundwater in an over 2,260 years irrigation district. I'm Gao Yanyan, come from Chang'an University. The outline is include these 4 parts. The picture on the right is the headwork of the Jinghui Irrigation Canal. It is one of the oldest canal irrigation districts with an irrigation history more than 2,000 years. The first part is the background. As we know, groundwater is an important water resource and is a key link in the ecosystem. It occupies 90% of all liquid fresh water, 50% of the world's domestic water consumption, and 13% of global irrigation water, so it is important for water, food, and ecological security. Irrigation is a large-scale and long-term human activity that alters the nature water cycle conditions and disturbs the soil and the earth balance. Currently, the global irrigation area is about 367.5 million hectares. And China is the largest irrigated country in the world. The total irrigated area in China is about 69 million hectares, and there are about 97 large-scale irrigated districts in the northwest of China. The picture is the distribution of main traditional irrigation districts in China. However, globally, more than 833 million hectares are affected by salinization, mostly in natural arid or semi-arid regions of Africa, Asia, and Latin America. And more than 1.5 billion people worldwide will face major challenge in food production due to the soil degradation. Meanwhile, more than 20% of the global irrigation area is facing water loss and groundwater quality deterioration. About 1.1 billion people live in areas where groundwater is blocked. This including seawater intrusion. If left unturned, the problem could expand more than 50% of the world's irrigated areas by 2050. Currently, the covered land affected by salinization in China has been as high as 5.66 million hectares. As we can see above, groundwater salinization and soil salinization has become common problems affecting the ecological environment in irrigation areas. Irrigation can meet the plant water needs and increase the green yield, and so ensure the food security. But irrigation management is not suitable. It will change water cycle, induce chemical reactions, and break ecological balance. Therefore, groundwater salinization and soil salinization are often closely related. To solve the problems of soil salinization in irrigated areas, it is very necessary to clarify the mechanism of groundwater salinization and understand how water quality affects irrigation management. The key is the hydrogeochemical processes. There are two key processes here. The first one is the physical processes. This processes will change the hydrodynamics of groundwater. When irrigated, the groundwater level will rise, and this will induce intense evaporation. With the water out and the soil remained in the groundwater system, it changes the water balance. The second process is the chemical process. It will change the groundwater hydrogeochemistry. When irrigation water will bring salt into the groundwater the the salt will go down with the irrigation water, then mixing and condense with the evaporation. And during this process, it will have some chemical reactions. This will change the salt balance and result in the groundwater salinization and the soil salinization. As we can see, the two processes, the irrigation is the driving force. So if no irrigation, how about the groundwater and chemical reaction? Here we compared between the irrigated and non-irrigated areas. The second part is the study area and the methodology. In this study, we choose Jingyang County as the study area. This county contains part of Jinhui Canal Irrigation District. This irrigation district is one of the oldest in the world. Its irrigation history is over 2,260 years, dating back to 246 BC. In this study area, gravity irrigation is adopted, and the area is dominated by the natural terrain. Due to the high terrain, the lowest plain in the north of the study area has no canal irrigation. At the same time, because of the war and historical changes, the irrigation area changed were differently. But regardless how the irrigation area changed, the rain terrace in the Jingyang has always been irrigated. Of course, due to the high terrain of the lowest tableland, no canal irrigation in the north of the study area. This picture is the cartoon map of the depth of groundwater table and the regional groundwater flow direction. In this study, the samples were collected from across the study area in August. This is including 104 groundwater system, 104 groundwater samples and 3 Jing River. The Jing River is the source of the irrigation water. And in this study, the factors control the groundwater chemistry are the first identified through the ratio analysis and hydrochemical methods, and then hydrogeochemical models is used to clarify the evolution processes in groundwater system. The basic idea of the hydrogeochemical models is as follows. Initial water chemistry plus reactants equal to final water chemistry plus products. Then the third part is the resultant discussion. From the volume plate for compare the characteristics between irrigated and non-irrigated areas, we can see that groundwater in the non-irrigated areas has low TDS, and groundwater in the irrigation district has high TDS. The paper diagram shows that groundwater in the non-irrigated areas are volcanic types, and in non-irrigation districts are complex water types. Soil isotopes of hydrogen and oxygen indicated that groundwater in the irrigation district experienced strong evaporation. From the spectral variation in TDS, cations and anions, hydrochemical types in the irrigation and non-irrigation areas, we can see that the groundwater in the non-irrigation areas can be simply clarified by low TDS and bicarbonate types without irrigation. Plus, there are no irrigation in here, so precipitation and lateral flow are the main source of the groundwater recharge in the non-irrigated area. In the irrigation district, the hydrochemical types of groundwater gradually transformed from the bicarbonate types to sulfate or the chloride type. The flat terrain prolongs the walk-rock reaction. Additionally, the recharging of the irrigation water disturbed the natural water cycle system. Rising groundwater levels at some locals and result in salt accumulation under the intention evaporation. Then the third is the hydrochemical processes. The hydrochemical processes form upstream to irrigation districts can summarized as methane evaporation, water and rock interaction. Methane means the rainfall, irrigation water, upstream groundwater mixed together and becomes the menstrual water in the upstream. Then it will aspirate. It will aspirate and from the groundwater in the irrigation district. Here we can see that the mixing and the evaporation is the cycle process, and then there also had some chemical reactions in the groundwater system. To calculate the net chemical reactions in groundwater system, a virtual solution was introduced to respect the mixture water after evaporation. Here, we use the water balance to calculate the mixing proportion and use the stable oil ratio to calculate the evaporation ratio, and use mass balance to identify the hydrochemical process and calculate the chemical reaction. Here we assume that the dissolution amount of the mineral A, B, and F during the hydrogeochemical processes, and the increment in the elements in the final water chemistry is dirt compared with the initial water system. Based on the mass balance, we can calculate the delta. The delta means the mineral or the dissolve or the precipitation of the minerals. Here we can see that the groundwater in the study area may also happen to highlight dissolve, dissolve causative precipitation, and there are also some carbon dioxide escape. At the same time, we can, based on the water balance, to calculate the dissolve of the highlight and the depth in the whole irrigation areas. Results show that the dissolve of highlight is about 22,000 tons per year, and the gypsum is about 30,000 tons per year. The dissolve of highlight and gypsum in such large amount every year will have a great influence on the sodium content of groundwater. It will increase the ions concentrations. Additionally, the large amount of caustic precipitation will greatly decrease the bicarbonate concentrations. Meanwhile, we find that the irrigation areas is a potential carbon sources. It will release about 6,000 tons per year. Yeah. Finally, we compared this old irrigation district with a young one. Here we choose Baojixia as a comparison, because both Baojixia and Jinhui Canal irrigation districts are located in the Guangdong land with similar climate and geochemical conditions. But the Jinhui Canal irrigation has occurred more than 2,000 years, but Baojixia is only occurred 50 years. The results show that the TDS, the mean value of TDS in Jinhui Canal irrigation district is about 1,790 and 19, but Baojixia is only 856. The groundwater type in these two irrigation districts is also completely different. The Jinhui Canal irrigation district has a complex hydrochemical type, but Baojixia Canal irrigation is mainly bicarbonate types. The last is the conclusion. From this study, we can see that we can get these findings like this. The first is the groundwater in the non-irrigated areas could be characterized by low TDS and bicarbonate types, but the groundwater in the irrigation district could be characterized by complex water types and high TDS. The second is the process forming the current groundwater system in the irrigation district can be summarized as mixing, evaporation, water and rock interaction. And the last is the lessons learned from this irrigation district is that long-term irrigation will lead to sterilization and complexity of the groundwater. Hence, therefore, in the water resource management of irrigation districts, we should pay more attention about the balance of the salt and the hydrochemical evolution of the groundwater. That's all. Thank you for your listening.
Thank you, Professor Yang. It's very nice and interesting presentation. I can see it's a lot of groundwater hydrogeochemical process. I think I would like to start the question from myself. I can see, as you mentioned, it's a complex hydrogeochemical system in your study area, complex type of hydrogeochemical system.
Yeah.
But I noticed that your ionic concentration table which you showed, it's sodium is more than the bicarbonate. The sodium percentage is more than the bicarbonate. Also, they're supposed to, if it is the more, you mentioned, its evaporation is more dominant in the area. So that means the sodium and chloride is supposed to be the more than the bicarbonate if it is evaporation is taking place. But my question I would like to ask, but it's through this process I understand it's a complex system. I understand that. Is there any irrigation return flow? Irrigation return flow. Your study area is a highly agricultural area.
Yeah.
So when they are adding more water, you mentioned it's a canal water irrigation, right?
Yeah.
In that cases, the fertilizers and all the sodium is infiltrating, it's reaching the aquifer. Is it? That is happened due to the irrigation. So maybe it's possible in that area, right? Irrigation flow. Actually, due to the agricultural activity impact in the groundwater system, will affect. Is it affecting your area? Yes, sir.
Yeah, your understanding is completely correct.
Correct.
Divert the river water for irrigation. And this kind of for irrigation and then in some downstream areas, the groundwater is all crop, and then it start into the greening.
Oh, that's good. Yeah. I think it's nice.
So thank you for the presentation. I just wanted to ask, as you discussed the mass balance for salt,
Mass balance.
for the irrigation land. So can the same be applied to other parameters like nitrate, nitrite, or phosphate from the same land as a deposition, as synthetic deposition? So can it be applied to same process can be applied
Yeah. Mass balance can be used for simulating natural nitrate.
Yes, yes.
So you need a mass balance.
Yeah, I think so. If you know what chemical reactions happens between there, they can use the mass balance. It is just like, for example,
Happening in the system. After that, you can make model. You can make a model.
What's it pointing?
Nitrate, nitrate, and ammonia, they will transform each other. If you understand all these processes, you can make a model.
Yeah, so depends on the sometimes it's a denitrification process, it's a nitrate. It's getting into the gas, nitrogen gas is removed in that process.
No, my clinic.
Synthetic evolution, we are talking, how much of time span we are talking about? Is it seasonal or we are talking?
No, in the clinic program,
we use the water balance here is the four times, yeah. Spring in
First, continue so children.
Precipitation is in the study area. Depends on the plant. Early growing of plant. Maybe for 2 weeks. Stop. Then during the summer, the evaporation is intense, and the plants need more water to grow. So at that time, they will start again. And I guess in September, maybe October, or even November, we have some plants. We have to irrigate it. So November, December is the winter.
Okay, good night.
Have some plants growing in winter. We have to irrigate again. So summer weeks for summer plants, we have 2 and one for the rotation, right? So another question.
So what will be the situation in case of arid or semi-arid regions such as South Africa? We have a semi-arid climate here. Will this process be more dominant? As like we have here semi-arid climate, so more evaporation, less rainfall.
Yeah.
So will this scenario be more prominent?
In study area, or in study the South Africa uses semi-arid area, more evaporation taking place. But this study area also it's more or less same like evaporation. I can see the sodium chloride dominant in the study area. Once the sodium chloride dominant in the area, evaporation is taking place. But that's what is happening.
Yeah, I guess it's a common process. When you irrigate, the water level will increase, right? Your elevate, and the salt dissolved in the water will also come up. And then during the evaporation, water evaporates, salt leaves in the soil.
So it's clearly mentioned that you're interested in that.
Handle this with care.
Any one last question.
Yeah, 1 and 2, that's fine. It's expected. The last one I looked at an entry point where now you can lobby with the farmers in the lower catchment. This is what we are seeing in our catchment. And you're using water for irrigation. And this is what's likely to happen in the future.
Not contained with care.
Can you put some 5% of your profit towards remediating the water that you're using for your own crops? I think a debate of sort of kind that if you are planning for a solution for these farmers, they should see what is coming into their resource, and they should see the threat of what will happen to the water and towards the production or activities. And maybe they can have a buy-in aspect of them. Let's look for the solution to solve this problem. Just to make use of your findings. Yes, it's good for these findings to stay in a publication, which is a thing that should be encouraged. But again, towards remediation, towards solution, the people who use that water also need to know what is happening with their water resource, so that maybe they may be willing to contribute.
There's no conclusion. No. Actually, my perception also what will happen due to the human population. But for example, my colleague but in the certain Asian countries, 365 days, the agricultural activity. The crop pattern is changing every 3 months. Relax the soil. So in that cases, what will happen? How much of you are having the fertilizers? It's settled in the agriculture. Then it's not only the soil, it's going to the, that's what I asked the irrigation return. So, but at the same time, as a management plan, management plan, you must go back 100 years. Stop all the chemical fertilizers, go back to the biofertilizers. But it's for current situations, it's impossible. But maybe we can control limited the fertilizers, maybe we can limit. Also based on the needs. So, but still many now there's still the
and I'm not lying.
now we are
I don't see nothing there.
bio organic food and non-organic. The time is going back in maybe the system. A lot of research is coming. There is probably also I reviewed many papers. Microbiome infiltration. How the microbes is infiltrated. Long acupuncture. These kind of studies can help to understand how process is going in the soil. I think last question, please.
I used to work as a soil physicist in the sugar industry, and we did a lot of soil and although we say South Africa is a semi-arid country, we do see human like and despite that, we have some degrees in because some of the farmers were irrigating water, basically worsening the situation through the irrigation. So salinization can happen even though it may not be semi-arid, although you would expect more in that semi-arid situation.
Thank you for this. Thank you so much. Thank you, Professor Go. Really, it's very interesting presentations. Okay, okay, I think it's the time is 1 o'clock now. I think better we can take break and go for the lunch. Almost lunch is ready. Maybe what time we can meet? 1:45 or what? 45 minutes is okay. Okay, we can meet again. Yeah, 1:45. Okay, quarter to 2. Okay. So colleagues, maybe you all can join the lines. Yes. Okay, I think. So they want to take one group photo before you, is it possible to die with that photo?
I thought they could have been postponed. Don't worry.
Okay. Oh, yeah.
We can have some people sitting. Yeah, yeah. Some people sit here, some people. Yes. Sorry. Some people can sit.
Yeah, maybe, yeah. Because I think the table is
Oh.
can sit.
Yeah. Yeah, some people can sit here.
Yeah.
And some people can stand there. Yes.
Yeah, I think that is going to be now. Second two here. This whole group.
The blue line.
Oh, it's not with the camera. I will bring it outside. Yes. So we can bring it out. Wait for camera. No, again, we don't have it.